So it's a pleasure to be here at the University of Chicago, where I taught 14 years ago. And it made me reflect how things have changed. I think this building is probably the same, actually. But I was in the statistics department, and I'm thinking about like the methods that I was working on and what I was doing. And setting aside me, just in general, I think much of the progress in the field of statistics, or now I guess we call it machine learning, has been about bringing ideas from the outside into the inside. So things that were considered to be paradoxes become theorems and methods, and things that were considered good practice become good workflow and eventually become methods and eventually work themselves into their theory. And in statistics, I'll just give a very simple example. If you go back, let's say, 150 years ago, people would say, well, I have some data, what distribution does it come from? It's like, this is like you look at old stuff, the Galton era of statistics. Oh, this should look like a bell-shaped curve. It must be a normal distribution. This is discrete. It must be a Poisson distribution. Then there'd be these data at it didn't look like anything. And so people try to come up with some sort of story. And then statisticians and econometricians and so forth develop regression models. And the idea that you don't have to explain all the data at once, which is commonplace to us. But if you think about it, what we're doing is taking the idea, like the old-fashioned idea of good practice would be, don't look at a heterogeneous distribution. If you have a distribution that looks weird, it must be a mixture of different distributions, and put them together, and generalizing that to the idea of regression, which allows you to do a lot more. Or another example would be multi-level models, where instead of people agonizing, even now you see people who don't know about multi-level modeling who will say things like, I have a study in city A and I want to make inference about city B. Does it apply or not? Maybe it does, maybe it doesn't, but really it should apply a little bit. You should think of a larger population. Or another example is statistical graphics, where statistical graphics has been considered good practice, but it's become much more integrated into statistical modeling, with the idea of graphics being a form of model checking. So when we do exploratory data, and I'll get to the replication crisis, don't worry. When we do exploratory data analysis, that means we're looking for, we've all done that, I hope. That means looking for patterns in the data that you didn't expect, right? So that's relative to an expectation. So data exploration is relative to models, because that's what an expectation is. That's obvious to us now, and it's obvious to us now that the more sophisticated our models, the more we learn when we can reject them, when we can find problems with them. So we construct models that might be a regression model, it might be an agent-based model, whatever it is. We kind of run our models forward and create fake data and compare to our real data and see how they're different. But if you go back 30 years, or 40 years, to the publication of Tukey's exploratory data analysis book, he didn't have any models in there. Because he knew about models. He was a great modeler, a brilliant mathematician, but he didn't have the conceptual framework, the theoretical framework by which graphics and exploration could relate to models. It took him doing it, and then it took the rest of us to realize that there was an implicit model behind what he was doing. And so we brought exploratory data analysis into the fold. Now we talk about replication. This is kind of the point. Of course, it's always been considered good practice to have replicable work, but it traditionally in social science has been considered good practice, not part of the science, but like something you should do to be a good person. And one of the signs of a maturation of a science is that practice, as I said, practice becomes workflow, workflow becomes method, method becomes theory, like that. Now, it's one thing it's very hard, at least for those of us my age in the room, is that there's an age period cohort problem. So is it that, over the past 20 years, I've become less naive and more sophisticated and more reasonable, or is it that the field has become more reasonable? And so I think like I've matured with the field, but it's hard to say. I know that my views have changed a lot, and I'll talk about that in a moment. But first, I want to ask, what's the role? Just consider what's the role of statistics, which might mean, when I say statistics, just all the things: design, data collection, experimentation, sampling, reliability and validity of measurements. Yes, things like p-values or Bayesian inference, but all the things, the design as well as analysis. What's the role of, I don't know, and I say this for two reasons. One, statistics professors spend about half their time teaching. We're supposed to basically do half our time is spent teaching and half our time is spent doing research. And depending on where we work, that teaching might be in the classroom, or it might be things like writing textbooks or blogs or journal editing, which is sort of a form of teaching also. When we teach, we tell our students that it's very important to have controlled experimentation. It's very important to have representative samples. Of course, we sometimes say randomized experimentation and random samples, but that's kind of wrong, because randomization is a means to an end. The goal is representativeness and balance. But we have all these stories. We love to tell the students stories about, like, ha ha ha, someone did the study and there was selection bias, right? They did that nurses study and they thought blah, 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 but actually the nurses who were healthier were doing blah, 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 and so that's why this correlation was there. And then they did the randomized experiment and it went away, ha 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 ha. Somebody did a survey once, remember, in 1930 whatever, and they got it wrong. You know, isn't that funny? They didn't do what we tell you to do. And when we're journal editors, we're like, blah, 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 blah. Oh, there's no identification. Goodbye. You know, your sample is not representative. You know, this is a great study if your goal is to learn about Mechanical Turk participants in psychology undergraduates, but we care about the real world. You know, either add a paragraph in your abstract saying this only applies to Mechanical Turk participants in psychology undergraduates, or do a better study. Or publish in PNAS. You know, you only have a few options there. So we're pretty firm about that, right? But yet, when we think of our own practice, so like when I decide how to teach, do I do a controlled experiment? Like, I'm going to try to teach one way or another way. How do I decide how to teach my class? I don't have a controlled experiment. I don't even, it's actually worse than that, because like, to do a control, not only, forget about randomization and all that, you actually have to define what your treatment is, right? Do I ever write down, this is what I'm going to do? No, I just show up and do stuff. And then if I wanted to measure how effective my teaching is, do I have a, like, I would need a measurement, right? Like a standardized test at the, okay, everybody raise your hand if you use standardized tests at the end of the semester in your college classes. Okay, great, that's one person. I should be like that too, but the others of you don't. So we're not doing what we tell people to do. Oh, but then of course that wouldn't be enough, because you definitely want to pre-test, because you have to, you know, control for differences between the two groups. Who never get around to doing that pre-test? And because it takes time, right? So in what's the important part of our professional life, we do not follow the recommendations we tell to others. So why don't we do it? Well, it's too much trouble. It's a lot of work. I want to just do the right thing already. I don't want to screw around, do this. I'm busy, like blah, 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 blah. So maybe it's no surprise that people who are trying to learn about the world, who are trying to study things as important to them as our teaching is to us, aren't really interested in these things that we're telling people to do. And I don't know the answer. Like, I don't know whether everybody should be using rigorous statistical design and they don't, and then therefore we're bad people too. Or maybe people shouldn't be doing it, and then we're teaching something that we don't believe ourselves. It's kind of weird, actually. So I was thinking about this because recently I get a lot of emails from people saying, I'm working at so-and-so institution, I want to do things right, but my boss just wants to publish results, and you know, they go through, root around in the data to find statistical significance, and what should I do? And I give them advice. There's a piece of advice that I give people. I have a generic piece of advice, which is if someone's doing something that you think is like bad practice, what you do is you say, do you know this? What you say, you don't say, I don't think this is a bad idea or this is unethical. You say, I'm a little worried that if we do this, the reviewers might say blah, 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 blah. Or, so I really think if we're really going to do this, I think in the paper we better be very clear on what we're doing so that we can preempt the reviewers' comments. So we better explain why this is okay. And so that should lead to a more open discussion. But anyway, this person sent me this thing, and he had some quote from the principal investigator who said they feel like all this good research is getting taken down because of like, you know, someone does good research, but they have some problem with their p-value, and then it gets attacked, and that doesn't seem fair. And it made me think that there could be a lot of people doing wonderful research that just happens to have really bad statistics attached to it. Just like I kind of like my teaching, even though I have no statistical evidence for it. And so I think that I thought about this, and I feel like if people are doing really good research and their statistics is really crappy, like they should just not put statistics in their papers, right? I mean, like no one's forcing them. Like if you have a really great idea and anecdotal evidence, you should give that great idea and anecdotal evidence. There's a lot of places for that. So, you know, maybe social science journals should have make a more clear role for someone for good ideas with anecdotal evidence, or where you're open about that. Now, I think also we have to then like realize that a lot of these ideas are wrong. I recently, like a year ago, someone pointed me to a paper that was published by political scientists that they had a pre-registered design, and then they did their experiment, and the result was, well, it went in the wrong direction, but it was statistically significant at the 10% level. And then they did about 20 interactions, and I think one of them was statistically significant. So that got published in a top journal and won 2 awards within the field of political science. And I kind of feel like if I were to say I don't think there is any good statistical evidence, someone might say that, well, but it seems like such a good idea, it's got to be true. But then it went in the opposite direction of the pre-registration. And so I want to illustrate, you know, this is an example of where the pre-registration was kind of helpful. I mean, it didn't stop the field of political science from giving 2 awards to this paper, but, you know, it gives us a little bit of perspective on it. Now, I think that I'm a good person to speak about this because I've done almost no replication or pre-registration of my own work. So social science, it's kind of hard to do. Like psychology, you can get another 24 undergraduates and do your study again. But like in political science, we can't say, well, we're going to do 10 more elections to gather, right? Or like, well, we're studying the effect of peacekeeping, so we're going to have like 20 more civil wars. Let's do a little experiment on that. And same with economics. So also it's kind of sometimes hard to do pre-registration because the data are already out there. So if you're studying the correlation between the economy and political popularity, I can't say, well, I'm going to pre-register a hypothesis about post-war American presidents and their election results in the economy because the data is kind of already out there. So in my career, I've had 4 papers retracted. Well, not literally, with corrections. So 4 times people found mistakes in my paper and I read corrections. And in 2 of those, the papers were basically completely wrong. Like the corrections just made the paper useless. Or maybe it was 2 or 3 out of 4. And then the other one was like a fairly minor correction, but I did that. So I've lived it. So I'll tell you that. I've published errors. And I've only done 2 pre-registered anythings really in my life when I'm moving towards. So one was we did an analysis of analyzing survey data and from 2008. And then there were some patterns in our analysis. I really didn't know what to believe. So we found more survey data from 2008, like a different poll. And we pre-registered our analysis and redid it. And that was really good. It took a lot just to write down our pre-registration. We published it, got the agreement from the journal to publish it. And after we redid the analysis, so we had everything but the analysis section written, all the code. Then we did the analysis, and immediately we found things that hadn't been in our pre-registration plan. And the other one is a study that I'm involved in now with Margaret Eckelbarger, who's here, who's a postdoc in psychology here, which is a political psychology study where we're giving people survey questions about political polarization. And I won't get into the details, but I'll say that based on my own personal experience, I typically get survey data and then I don't really think about how to analyze the data. So I just have tons of survey data I'm always gathering, and then it just sits around and I never do anything with it. So this time I thought we should do the analysis before we got the data. So that means you need to write a computer program to simulate fake data. And it's actually harder to simulate realistic-looking fake data than to analyze fake data, right? Just like it's easier to say hi to somebody than to build a person to say hi to, right? So we haven't even collected our second round of data yet because it's been so difficult creating that. So it's a lot of work. So I feel your pain, is what I'm saying. So usually we're almost out of time here, but usually in a talk like this, I would first talk about all the problems of social science and give you many amusing examples of a mixture of plausible claims that didn't replicate, plausible claims that, although they seem plausible, if you go back to the study, you realize the data were too noisy to ever learn anything useful, ridiculous claims that got published, and to establish the existence of a problem. But I don't think I need to do that for you, so I won't. Instead, I'll jump straight to the solutions. And I think there are three classes of solutions. And I labeled them as procedural, design and data collection, and analysis. And we hear most about the procedural solutions, and I'm going to kind of say least about them because I'm not an expert on this, or maybe everybody's an expert on this. So first is reducing incentives to cheat, right? I mean, so people talk about incentives. And related to that is increasing incentives for criticism. So that's kind of obvious that it's like for reals. Once someone sent me a paper, it was in the American Sociological Review, so probably none of you ever saw it, but it had some flaws, and I was encouraged to write a letter to the journal pointing out the flaws. So I did so, and then they sent it to 3 reviewers, and then the reviewers were like, yeah, this is a correct criticism, but this letter is not important enough to be published in the American Sociological Review, like, because publication in the American Sociological Review is a great honor, and we can't just bestow this honor to little technical corrections. So it made me realize, well, journals have at least like 2 roles here. One is to publish things, and the other is to confer honor on people. And I felt like, since I'm not a sociologist, couldn't you just like put an asterisk in my letter, like, this letter doesn't really count? It's not about honor, it's just about getting it right. And they said, well, if it's just about getting it right, why don't you publish it in sociological science? That's their ambit. So I didn't end up publishing it there, but it clearly, like, the incentives are kind of screwed up. Actually, medical journals are much better. They publish letters of criticism all the time. I like the idea of post-publication review for efficiency reasons. So there's a funny thing. You raise your hand if you've refereed journal articles ever. Yeah, okay, some of you have. And every journal article that gets submitted just about gets reviewed 3 times, except bad journal articles might get reviewed 6 times or 9 times or 12 times or 15 times. Because remember, everything gets published. It's only a question of where it gets published. So actually, the worse the article, the more pre-publication reviews it gets. And lots of articles get 15 reviews and only 16 people have ever read the paper, right? including the author, of course. Now, post-publication review is kind of more efficient because people only do post-publication review if they feel like it. So it suggests that maybe we should be moving towards a review system like that. But again, I don't really have any special expertise on that, just personal experience. Now, design and data collection, people sometimes talk about getting a larger sample size, but I think that's usually not the right way to go, that it's better to get better measurements. That just takes a little more work. And there are two reasons why better measurement is more important than larger sample size. So one is that if you reduce the standard deviation of your measurements by a factor of 2, that corresponds to increasing your sample size by a factor of 4. Right? So you have this squaring effect that a small benefit in measurement accuracy is going to be much more effective. The difference is that larger sample size you can solve using the application of money, but better measurement requires thought, and that's not so pleasant to people. Then, in addition, there's this vicious cycle. So it goes like this: someone does a study with bad measurements, but they found something statistically significant. And then someone says, well, your measurements are too noisy, this is useless. And the person says, no, our result is statistically significant. So that retroactively means that the only purpose of the measurement is to get your variance down, and the variance must have been low enough because you were significant. But that's not recognizing that you can capitalize on chance. The other thing is a lot of bad measurements are biased. Lots of examples. My favorite one was the study a few years ago that claiming that women were 20 percentage points more likely to support Barack Obama during a certain time of the month. And it turned out that the study mislabeled which were the days of peak fertility. And it's because, like, I actually know this because we had our third child when we were in our 40s, so we're very aware of what are the days of peak fertility. Like, you learn this. I think the people who did this study were like these young people, so they just remembered like what they told you like in health class in 7th grade, like, oh, any day it can happen, whatever. So it was like, no, day 6 is not peak fertility. I'm sorry, it doesn't work that way. Anyway, so what you have is a bias. You're measuring the wrong thing. Now, traditionally, here's a little technical point I'll make for you. Traditionally, say, oh, we don't care about bias because we're doing like a random sample survey or a randomized experiment. So we're comparing two groups, so the bias should cancel. So sure, I'm measuring the wrong thing, but I'm still estimating the treatment effect, right? It's just because there's this general idea that if you have a randomized experiment, bias doesn't matter in your measurements. But that's wrong, because if the treatment effect can interact with the bias, that is, the bias can be different for different people. The treatment effect can be different for different people. You have an interaction in your model. Then all of a sudden, like, all bets are off. So in some ways, some of the mistakes that people have made have been kind of ideological. Like, not political ideological, but methodologically ideological, that people have been told things that are simplifications. And it would be a little like you get high school chemistry and they talk about the orbitals and the bonds and all that, and then you're convinced that two chemicals, like if you mix them, they won't blow up. But actually there's a little bit more chemistry you didn't learn, and then your house blows up, and that's like too bad. So that's kind of what's happening here. Now, so I do believe better measurements and within-person designs would help in a lot of studies. Now, a lot of people don't want to do a within-person design because they're worried about poisoning the well, right? You know about poisoning the well. Like, you ask someone a survey question, the traditional design is you do one thing to some people and one thing to some other people, and then you compare. It's much better to do the same thing to both person and compare. But if you do that, they might remember what you did. So you have to wait like 5 minutes. Everyone forgets everything in 5 minutes. Now, of course, there's a bias if you do a crossover design because the well can be poisoned by the first thing. I think we should be less worried about poisoning the well than we traditionally are. And I'll tell you a couple reasons. So the first reason to be less worried about poisoning the well is that I think people do forget what you did before. Three reasons. That's the first. The second reason is the alternative of the between-person design. That if you're studying within-person phenomenon with a between-person experiment, you're going to have so much variability. You're going to be very subject. Variance and bias are both going to hurt you, and they can both go away with a within-person. And we have a lot of experience of this, that designs which look very rigorous actually are so noisy as to not be useless. And I use the analogy, that the kangaroo analogy, that you want to weigh a feather by putting it in the pouch of a kangaroo and having her jump vigorously up and down on a scale. And that's not a good way to weigh a feather. Right? So if your measurements are noisy enough, things aren't going to work. The final reason why within-person designs should not be discarded is that life is a within-person design, right? So if I'm considering, let's say, two different potential interventions to affect voter turnout, and I say, well, I want the pure effect. I don't want this between-person comparison because I don't want a within-person comparison. I want this between-person thing because I want this pure thing. It's kind of weird because real interventions in the real world are all being done all overlapping each other. So we wrote about this in our GADAR paper too. So there's the thing about the tyranny of measurement. People feel like a lab, even a field experiment, should be laboratory-like to isolate your treatment. But actually, real world, these things are not isolated. And so it's not really realistic to expect large effects of things. And so I want to conclude. Do I have 2 more minutes? Okay. 5 more minutes. Okay. You know, I want to conclude by talking about incremental effects, and this relates to analysis. So, you know, the low-hanging fruit are gone, right? No matter how old you are, it's the previous generation did all the easy stuff, you know? And you're coming in and, there's no easy things, right? All the great phenomenon that are obvious, people already studied, and now it's time for you to study more difficult things. And, well, that's true in social science. In medicine, it's actually considered unethical to study large effects, you know that. Because, they don't say, I have a new treatment for heart attacks. What do you compare it to? The placebo? Oh yeah, you either get the great new treatment or we're going to sit you out in the street and see how long you live. No, of course not. They compare the new treatment to the best available alternative, similarly in education policy. You don't say you're either going to get our new education plan or the kid's just going to sit in front of the TV for 12 years, right? It doesn't work that way. It's unethical to study large effects. So of course, if you're studying small effects, you can forget about getting, regularly getting definitive evidence for things. So that suggests that it's at a technical level, I think we should be using multi-level models and stronger priors that partially pull estimates towards zero. We have to think about a new idea you have in the context of many other ideas. One framework I kind of like that I encourage you to think about is in industry they talk about A/B testing. Have you heard that term? So experimentation, because you have you're going to design a new product or you have a new way of advertising or whatever, and you're going to compare two different things. The essence of A/B testing in industry is that a company that does that will have many potential interventions coming in, and there's a stream of these things. So it's very much like the community of social science. So multi-level or hierarchical modeling is natural because you actually have a population of effects you're interested in. But studies are typically presented as here's this one study all by itself, but it's not that way. So I encourage you to think about the A/B testing framework and think about the goal of social science as being to make progress rather than to get definitive results. And now I'm going to really conclude with the title of my talk and why I say it. So the title is Honesty and Transparency Are Not Enough. And I've been thinking a lot about this because often So sometimes you'll have some scandal, someone does something they shouldn't do in science and they get disgraced, and there's a discussion of what moral failures they had. I've decided I don't like the term p-hacking because it implies intentionality. And I think that there are two problems with this. And the first problem is that it's not fair. People do bad research, but it's not on purpose. They're using bad methods, and they've been, and so to say they're hacking and cheating is not fair to them at all. It's just immoral in some way to accuse someone or describe someone as being dishonest if they're not. The other thing, it's the reverse, which is someone happens to be honest and they're doing bad methods. And then they say, well, no, but I didn't p-hack. I've had this happen. People, we find a flaw in someone's paper and they say, no, I didn't do that. I only looked at one comparison. Well, you can still have statistical problems. But so by trying to identify statistical flaws as moral flaws, what that does is it sort of encourages people to let themselves off the hook. Now, where do I think we're going in the future as social science? That I think we're going to move towards greater uncertainty, and I think we can value research without demanding that it reaches a stage of statistical significance. I'm happy to set the statistical significance threshold to nothing at all. I don't think that we should have any statistical significance threshold. I think that's a ridiculous idea. I think we just have to accept that we have uncertainty, and there's a lot of value in partial work. Maybe if we can be more open about that and more willing to see that we can make mistakes, then we would be less tied up in a lot of these. I mean, sorry. Let me say one more. I'm sorry. It's like I don't want to end there because that's like happy talk, okay? And I think that, like, I want to end by saying I think that our technical work is important. That something like a p-value is like maybe it was useful 100 years ago. It was technical work that served its day. But the things that we're doing now with multi-level modeling and post-stratification and things like that, I think that can help us do better research. And I think we have to be open to that. The idea that a lot of these things that have been presented as kind of moral failings really, I think, do have technical solutions. So as a statistician, I would like to end with that. I love post-publication review. I bet most of you do, right? You write a paper and you send it to everybody you know, and they just don't even read it. I mean, like, it's thrilling. I mean, when people give you criticisms, you know, like that's good news, right? Like it's great. Like it's even better if I made a serious mistake and people told me, like I'd want to know, right? It's like if your kid was doing drugs and someone tells you, you'd thank them for telling you. You wouldn't be like, hey, how come my kid, you know, like it might be bad news, but conditional on it existing, you want to hear it. So first, I'm just baffled by people who who don't want criticism. I think I can't relate to these people. So I'm probably the worst person to answer that. But I'll say this, so as you know, I mean, the field of economics or microeconomics has two strands. One is to observe something bad that somebody is doing and explain why it's actually rational and a good thing and we shouldn't complain. And you know, the other thing is whenever they see people doing anything nice, they explain why it actually has negative, unexpected consequences and why we shouldn't be doing it, right? So those are the two branches of microeconomics. And this relates to a fundamental insight of microeconomics. So the first insight is that we are always at a local maximum, a local optimum. And the second insight is that there are global optima out there that we're not there. So the purpose of the first attitude of microeconomics, of identifying what people are doing and treating it as rational, is to understand the rules, the landscape under which we are at a local maximum. And then the reason for the second part of microeconomics, which is to say why you're doing everything wrong, is to search is to use their fabled taboo-busting characteristics to find places in the larger landscape and see if we can jump to those things. So what's the local optimum now? Well, besides like setting aside things like various comfortable people who have jobs and like play the academic game and want their students to get good jobs and blah, 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 and publishers that make money, there's also thousands of people like me who review papers as volunteers just because like we kind of feel bad, you know, to say no to our friends or our colleagues. So one of the difficulties of moving to any new system is all of that free labor would disappear. There's no way that you could like, so there have been, people have attempted to create various zip lines to get from here to there. Perhaps not the right analogy, because if you're at an optimum, you'd want to go up and the zip line goes down. So, but anyway, so like there have been ideas like overlay journals. So it has all the prestige of a journal, but it's post-publication review. So there are some journals like this where they find papers in like SOCI archive and things like that, and all they do is write, like say, this is our virtual journal and we've post-publication reviewed it. There are a few ideas like that, but I guess that's my only comment is like to get there like would require that kind of bridge.
How do you think issues that are politically contested should be addressed? Like take whether school vouchers improve education, or does open immigration raise employment or lower employment of natural-born Americans? Like where there is a really big ideological divide, and there are a lot of tendentious studies being done by people with an interest in promoting a view. But what do you see as the role of people actually settling some questions based on facts and reason?
Oh, I don't know. I mean, I don't think I have anything to really contribute to that. I only say that I don't think it's so great to phrase things as like, well, here's a hypothesis that like charter schools are good or they're bad or whatever. I think it's better to be more specific and like to say that like most things have some good effects and some bad effects. I mean, you still have to that won't make things unpoliticized, but I mean, what's really weird is a lot of things are politicized in science that have no political content, right? So like someone will make a claim and then they're attached to it and then they start fighting about it. And I think I've noticed like a lot of research, a lot of bad research, like people like, it's like what you said, people just like it because it seems generally supportive. So you have people who like evolutionary psychology and they'll like every paper that's ever been published in evolutionary psychology, no matter how bad it is, because it supports their general view of the world. And what I always say to people like that is, that's fine. Like if you want to respect every paper that's ever been published on this topic, you should also accept every preprint on this topic and every scrawled note on this topic. Like it's like, and you know, at some point you have to have some discrimination. But I don't know. I mean, like immigration policy, like you just have to get technical on the details. But ultimately, the policy is a separate issue.
Hi, I was wondering about your point that there could be really good research being done with bad stats attached to it, and in those circumstances it makes sense to remove the statistics. I wonder if you think of this at all, or if people are discussing this as having research being done at different stages in the research process, each of which are valuable. So there could be research that's done with data presented that sort of acts as a plausibility probe, and it's meant to be at an earlier stage in the research process, but is still viewed as necessary. I wonder if you've sort of thought about that framing, or if you think it's at all helpful.
Well, you know, I always think of like Jean Piaget. So he wasn't quantitative, and he had a lot of insights. Now, apparently he made a lot of mistakes too, but that happens, right? So I don't think Piaget's work would have been better if he had had to present statistics. I mean, maybe it would have been a little better. He could have gathered more data, but it also could have been worse, because then he might have been under pressure to like present these very firm claims. So by being qualitative, it was just more open. And I mean, a lot of ideas in education research are kind of qualitative. Eventually, people do try to study it. But one of the things, there's a paradigm in like medical or education research, and it goes like this. People do qualitative research, like they understand the mechanism, like in education research, they talk to the kids. In medical research, it's a lot of lab research, and then they come up with a treatment and then they test it. And then that's this big thing. But often what's most important is what flavor of the treatment you test. And your study, your quantitative study, it's very hard to use that to get definitive claims on which flavor of the treatment is more effective. I mean, that's an interaction, and the rule of thumb is you need 16 times the sample size to estimate an interaction as you do to estimate a main effect. And so it's kind of, we're really relying so much, like, whether we admit it or not, we're relying so much on our substantive and qualitative understanding, because like we could never use the quantitative stuff to decide what we're testing in the first place. And I think there's a lot of naivety around that.
Thank you. Thank you for your talk. I enjoyed it. I gave a paper once. I do work on the Holocaust and how people keep their humanity during war. And I gave a paper in Finland, and someone in the audience says, I don't accept your conclusions because you didn't do a controlled experiment. And I wasn't quite sure how to respond to that, because no one would ever do a controlled experiment with something like that. There are a lot of issues and topics and questions in political science in particular, but I think in social science in general, that are very important, but you would never do in a controlled experiment. In some ways, it's not even clear that you can use statistical data for some of those. So how do you develop standards for evaluating good research then?
Well, yeah, I mean, I've done almost no controlled experiments in my applied work. No, I think at some level, they don't have to accept your argument. I mean, that's actually true. I mean, like if you're making a statement in your research about, I mean, it depends. So like, I don't do controlled experiments, but I do a lot of descriptive things. So if someone says to me, I don't really believe that rich people in Texas are more Republican than poor people in Texas, I can say, well, we have surveys, right? So then they can say, well, the surveys have non-response. Like, they might be right. But if you're making if your statement has, I mean, people don't have to believe, this is like, that's fine. I mean, like, you can't, like somehow it's not like convincing people is not always going to be possible, and maybe it's not always appropriate. Maybe we try too hard to convince people, and we don't try hard enough to just sort of present our reasoning. I mean, in a very theoretical way, I think, like, suppose, take the previous question, suppose it's something about immigration policy, which we don't have experimentation of, and someone does a natural experiment, and then someone says, well, I don't believe you, there's no controlled experiment. Then the role of statistics and technical work is to elucidate the assumptions. So for me to say, just like I would say in my survey analysis, well, if this survey were really a random sample of the different subgroups of the population, then I think my claim was true, right? And then people could argue on the assumptions. So I think you can certainly go to the level of the assumptions. And for that matter, that's true in a controlled experiment too. Controlled experiments, almost always controlled experiments, the interpretation assumes an absence of interactions. And that's an important assumption people don't state. So a lot of social scientists have this view that the chain is as strong as its strongest link, right? So blah, 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 but I did a randomized experiment, therefore everything has to be true. But that's, of course, if you have the wrong measurement, then it doesn't matter. Well, you all are such good questions. I mean, usually I give a talk and people like laugh at all my jokes and they don't ask a single question. And you all were stone-faced and didn't laugh at all because it's, I think it's because it's early in the morning. I have a friend, Mary Sarah McPeak, who's a professor in the statistics department here. And when I taught at the University of Chicago, we taught a class together, and she said to me, "You're too much." She said, "Your content is great, but you talk in too much of a monotone. You should do this and get excited." And I forgot to do that. Before this talk, I was reminding myself to do it, and I forgot. And so I want you to pretend. I'll work on that for next time.
We laughed at your microeconomics joke a second ago.
Yeah, well, but sure, but that's like, I mean, that's too, you know. Yeah, okay.
I have a question about your comments on the state of publishing code in academia. I mean, I've seen code from different levels of inscrutability, and I'm thinking primarily of models that have very sophisticated mathematical theory. The code that goes with that's very difficult. In terms of openness, what do you see as potential problems there and maybe solutions in making code more transparent?
Oh, I think publishing code is great. I have like hundreds of papers that with no published code, you know, things are changing. No, it's only fair. Like if your code looks really bad, then maybe it can't be replicated. People should know that. Like the motivation for publishing clean code is similar to the motivation for writing clearly. That if you publish a paper with ugly code, someone can see it and say, well, if it's a methods paper, well, gee, I'm not going to use this method, it's too complicated. If it's an empirical paper, why should I believe this result if I can't follow the code, right? But yeah, I mean, presumably publishing code would, I mean, so I think that kind of will, to some extent, solve itself. That I think there are very few cases where people can intimidate you with their code. There's, you know, if your code is, if you publish the code and your code is unreadable, then very rightfully so, people won't respect you. It's like what I said about that guy who refused to share his data. I said he has no requirement. People are angry, like, why won't he share his data? This guy, like, he's, you know, let's call his university, let's make him give up the damn data. And I said, he has no obligation to share his data, and I have no obligation to believe anything he's written. It's fair, you know, like there's no, it's symmetric. We shouldn't go around telling people what to do, right?
Hi, I'd like a little more clarification in your statement about how you don't think there should be any threshold of p-value. Now, I understand that it doesn't make a lot of sense to pick one arbitrary value for all studies, and of course there are times when statistical methods aren't necessary or maybe aren't appropriate. You know, we have a model of the cell, it wasn't built on p-values, it's built on a different kind of observation. But when you are working with p-values and somebody has a p-value of 0.5, then do we learn anything? Like, how do you, once a p-value is big enough, isn't it totally non-informative? Am I missing something?
No, I think, you know, certainly it's very reasonable to say that, like, our data could be, you know, let's suppose I'm comparing two treatments, and the data appear to be so noisy that, like, they're consistent with either one being better, then that would motivate gathering more data. But it would motivate publishing what you have so far. So you publish what you have and you say there's a lot of uncertainty. And we recommend gathering more data, or probably better still, gathering more relevant data, gathering more precise data. But you see, if you say you can't publish until you get that significance, then there's this information out there. So, for example, that paper that got the 2 awards, you know, that was all basically all noise. What if they had published it and said, well, we did this experiment and it didn't, we had a pre-registration and everything looks like noise, so don't do this experiment anymore. Like, there's a problem. Instead of saying, oh, we reassessed and we realized that our original hypothesis was exactly backward and now we have a great explanation for why the other thing. What if they had said, we reassessed and we realized that it's harder to measure this than we thought, that the effect is small. Publish that. Why not? Okay, so you don't get 2 awards, right? So big deal. You know, we don't need 2 awards all the time. So that's what I mean. I don't mean that, oh, the p-value is 0.4, so you can now make a decision and be confident you're correct. I just think something like a publication threshold is limiting our ability to learn.